In this video, I'm going to pick some problems from assignment 1 and go over them for you. And hopefully when you do your assignment 1, obviously your numbers and answers are slightly different, but you'll be able to understand what it is that you need to do. In this first question, it comes directly from the video I just made for you on the basics of math. Determine which property is illustrated by the given equation. So we want to look at the equation up there on the top. And what we notice is that we have a 4 plus, parentheses 9 plus 8, equals, parentheses 4 plus 9, and parentheses plus 8. What have we done to the equation or the expression on the left to end up with the expression on the right? Well, notice that the operations are addition on both sides. The three numbers are exactly the same. All we've done is by moving the parentheses, changed the order in which we're looking at those numbers, or we've associated them differently. So we call that the associative law of addition. So where is that? Associative property of addition. That's the second one down. So that's the associative property. If you're not comfortable with which property it is, I've given you a review from the last video, and it's the slide before this one in the homework slides. So bring up your homework slides and you can use it for this as well. All right, so let's take a look. Let's skip ahead to problem number 3. Now looking at this one, state the name of the property illustrated. Well, as I look at it, we are multiplying 1 over y minus 4 by what's in parentheses, y minus 4. And what we're getting is an answer of 1. Well, it's a multiplication of two things resulting in the identity, which is 1. When you find an expression and you find something you multiply by to get 1, you're talking about the inverse property. So this would be called the inverse property of multiplication. Well, let's skip ahead again. Let's go to number 6. Now, let's use some of our knowledge to simplify this expression. Now, a couple of things come up in this one. One is what we call the order of operations. Now, the order of operations is less a law than it is a convention, because as we write longer equations, we want people to know what is it we really mean by that. Well, we've come up with a way to remember that, and our process is this. We come up with the saying, please excuse my dear Aunt Sally. Now, some of you may have seen this in the past, and you say, well, gee, you did that wrong. It should be my, then dear, then aunt, then Sally. That would be true if we believed in division and subtraction. But I've already told you, those are no longer operations for algebra. So my dear just is recognition of multiplication and division are the same thing, and Aunt Sally on the same line is a recognition that addition and subtraction are really the same operation. So what do these things mean? Well, please, we really look at the first letter, the P, the E, the M, the D, the A, and the S. So please stands for parentheses. E stands for exponent. My stands for multiplication / division. And A stands for addition slash subtraction. That's the order in which you do things. So the first thing is parentheses. Well, I have parentheses up there. You'll notice I have soft parentheses that we're used to, plus hard parentheses, sometimes called brackets. The only reason that my math lab uses those is it makes it easier to see where parentheses begin and end. But there's no difference between the hard bracket and the soft parentheses as far as meaning. But we must start at the innermost parentheses. Well, that's the x squared minus 8. And we ask ourselves, is there anything inside that parentheses that I can do to make it simpler? Well, you cannot add unlike terms. Unlike terms meaning one has a letter in it to a power, the other one either doesn't have the letter or has a different power. So the x squared and the negative 8 cannot be put together. Notice I call that a negative 8, not subtract 8. That's x squared plus a negative 8. If you look at it that way, you'll see later why it's so important. What I can do, though, is I can go outside that parenthesis, still staying within the hard brackets, and notice I have an 8 in front of that parenthesis. That's the distributive property. That 8 is multiplying the parentheses, and I have an addition going on inside. So that's the distributive property. Remember, you must distribute to both entities inside the parentheses. So that's going to be 8 times the x squared and 8 times the negative 8. So let's do that. So we'll keep the remainder the same. So we'll have 20x squared plus 1 minus bracket. Now we're going to multiply the 8 through the distributing process. So that'll be 8x squared. 8 times a negative 8 is negative 64. Then we have a plus 4. The 8 doesn't come that far. Okay. So now inside parentheses, I have 8x squared negative 64 plus 4. Now, can I simplify anything in there? The answer is yes. The negative 64 and the 4 are both like terms. They're whole numbers. There's no variable. There's no letter there. So therefore, the negative 64 and the 4 can be combined. Well, if I have a negative 64 and a plus 4, that means I'm going to come up 4, so now I have a negative 60. Now what do I do? Well, I have a negative in front of that bracket. That means I need the additive inverse of what's in that bracket. Remember, the additive inverse is what you add to that to get to 0. So what would I add to the 8x squared minus 60 to get to 0? Well, I must get rid of the 8x squared, so I'd add a negative 8x squared. And I would add 60, so I'd have a positive 60. So the additive inverse, negative sign outside means additive inverse, of 8x squared minus 60 is a negative 8x squared plus 60. Now, you probably did this before by multiplying through by negative 1. You can do that as well. And what you'll get is 20x squared plus 1 minus 8x squared, but the additive inverse of negative 60 is plus 60. And that's one of the places that I see mistakes quite often, is forgetting that this is the negative inverse of this whole expression inside. So therefore, the second expression there must be changed as well, second value. Okay? Now, I can collect like terms again. And notice I have a 20x squared and a negative 8x squared. See how much better it is to assign that little slash, or that little hyphen, meaning negative sign, to the number that follows it. Rather than calling it subtraction, what this means is I have a positive 20x squared and I have a negative 8x squared. Well, if I put that together, I will end up with 12x squared. Now I have a positive 1 and a positive 60, That adds together to give me 61. Now I've simplified that quite a bit from that original expression up there down to here. And that would be my answer. So let's save that. You all can look at later. Now, let's move ahead to problem number 9. And this comes to plotting points. So how do we plot points on a graph? Well, first of all, the horizontal axis, as we call it, which I call a measuring stick. It's measuring how far we are horizontally. Notice the middle is always 0. So we can be 1, 2, 3, 4, 5, 6 to the right, or we can be 1, 2, 3, 4, 5, 6 to the left, but those are the negative sign, negative numbers. Likewise, we can go up 6 and down 6. Well, what are the numbers that we're trying to put on that graph? The point in the way they express it is always going to give you the horizontal or x value first, and then the vertical or y value second. So let's take a look at 3/2 comma 5/2. Well, first of all, this is the x and this is the y, because that's the standard form for expressing a point on a graph. So 3/2 is the x. How do we do this? Well, you take your mouse, and let's see, when I do that I'm going to lose my numbers. So just, so I first of all want to take the point and move it to the right 3/2. Well, 3/2, let's see, 3/2. Wow, that's a fraction, isn't it? We need to talk about fractions. But 3/2 are 1.5. If you look at a fraction as the number on the bottom telling you how many slices there are in a pie, then that pie is cut in halves. And if I had 3 of those, that would take more than 1 pie to get there. It would take 1.5 pies. The second one, 5/2, if I was cutting my pies in half, but I wanted to feed 5 people, I would need 2 pies plus another half. That's 2.5. So at any rate, let's plot 3/2. So let's move the point over 3/2. That would be 1.5. So there's 1, there's another half. And then we want to go up 5/2. So we go up to, 2.5, and we put it right there. Okay. Now, one of the ways to graph things is to pick some points first before we graph them. And we build what's called a T-chart. This is what they're going to build here. We're going to evaluate that expression y equals the absolute value of x minus 1, where x is minus 3, minus 2, minus 1, 0, 1, 2, and 3. So this will keep building as we go. Well, let's see. Absolute value, what does it mean? Some people would say, well, the absolute value is just the positive value of any number. And that's a good way of saying it. So the positive value of -3 is 3. The mathematical way of saying it is it's the distance from 0. But if you think about it, that gives you the same answer. If I go -3, how far away am I from 0? I'm 3 away. So it's the same result. One is more professional in the math sense than the other, but that's fine. We will get to the same place either way. So if I take y equals the absolute value of -3, I will get 3. Minus 1 would be 2. So my y value here would be 2. Now what about at -2? Well, the absolute value of negative 2 is positive 2 minus 1. Well, 2 minus 1 is 1. What about negative 1? Well, the absolute value of negative 1 is positive 1. And then subtract 1, we would get 1 minus 1 is 0. What about 0? What's the absolute value of 0? How far away is 0 from 0? It's 0 away. It's the same. So the absolute value of 0 is 0. Minus 1 would be minus 1. What about 1? Well, let's see. The absolute value of 1 is 1. Minus 1 is 0. The absolute value of 2 is 2. 2 minus 1 is 1. Notice we're beginning to repeat some values from above. And the absolute value of 3 is 3. And 3 minus 1 is 2. Now, which one of those graphs illustrates this? Notice that the x's are my horizontal values, my y's are my vertical values. So when I'm at negative 3, I'm supposed to be at 2. Well, this C would not work for me. It looks like A might be a good one. Notice those little, what we call ticky marks, the little lines, are every 2. So if I go to negative 3, my value is going up, would be 2. B doesn't seem to work very well. So D is a candidate, but let's see. Maybe what I ought to look at is what happens when x is 0. Because when x is 0, I am on the what's called y-axis, the vertical axis. So when x is 0, y should be negative 1. It should be down 1. A is that way. D is not. D is sitting at positive 1. So therefore, A is my answer. Okay, let's move on to number 15. Identify the intercepts of the graph. What are the x-intercepts, if any? Well, x-intercepts, they're like intersections, where you intersect the x-axis, meaning you cross the x-axis. Well, remember from before, the x-axis is the horizontal axis. So where am I crossing it? It looks like I'm crossing it at negative 6, at 1, and again at 7. Those are the numbers for x, where I'm crossing the x-axis. I'm crossing negative 6, 1, and 7. Well, to put those answers into my math lab, we want to put them in and separate them by commas. So we would say negative 6, comma, 1, comma, 7. Now what about y? Where are we crossing the y-axis? Well, y is the vertical axis. So I go up and down the y-axis looking for the blue line crossing it, and I see it crosses where y is 2. So therefore the y-intersection would be 2. All right, let's look at, let's go ahead to number 18. Determine whether the relation is a function. Now, when we talk about a function, the nature of a function is that we are relating x values and y values together in some kind of relationship. But further than that, a function says that for each x value, there's only one y value. So as I'm looking at pairs of numbers, remember the first number is the x, and the second number is the y. So the 1 and the 4, the 1 is an x, the 4 is a y. the second number, or second pair, the 6 is an x, the 5 is a y. In the third pair, the 7 is an x, and it relates to a 7 on the y. Well, what I'm really looking for is this. Is there any x up there that is related to more than one y? Well, the x's that are up there are 1, 6, and 7. The 1 is only related to 4. The 6 is only related to 5. And the 7 is only related to a y of 7. So therefore, this is a function because each x is only related to one y. So we would say, yes, this is a function. Now, what would make this not a function? Well, if it was not a function, we could have had, so I would say if not a function. What we could have had was 1, 4, 6, 5, 7, 7, and then maybe 1, 3. Notice in that set, I have two values where one is related to two different y's. One is related to 4, but also one is related to 3. That would be not a function. But the one we had is a function. The domain. Well, the domain is merely the values that x can assume. So in this case, x can assume 1, 6, or 7. Those are the x values. So we would list those out with commas. 1, comma. Oops. Let's save this first. 1, comma, 6, comma, 7. And what about the range? Well, the range are all the values that y then would end up assuming after you had defined the x's. So the y values are going to be 4, 5, and 7, the second numbers in each pair. Okay, let's save that. Now, looking at 21, we're getting into something here called translation. How we move a graph around and what causes a graph to move around. Well, what we have up here is our two functions, f of x, which is x squared, and g of x, which is x squared minus 2. The key to it is that that negative 2 is going to take each value of x squared and take it down 2, because it's subtracting 2 before it gives you your y. Therefore, we're looking for a graph that is just like f of x, but g of x is down 2. Well, let's see. If we look at these graphs, first of all, we need to find f of x. F of x is what's called a parabola, and that's the simple x squared parabola. And if you were to put together a t-chart and plot it out, you would find that when x is 0, 0 squared is 0, therefore y is also 0, and that is f of x equals x squared. Now, if you took every value on this graph and subtracted 2 from it, you would move it down 2. So look at D. D shows this graph, and then it shows another graph coming down and back up. It has moved it down 2. So D would be our answer. So let's move out to number 24. This looks complicated when you first see it, but if you work it through step by step, it isn't that hard. So we have two functions, f of x and g of x. F of x is defined by, for every value of x, you first square it, then you take the negative of it, and then you take a negative 2. Add those together. G of x is taken as negative 4 times x, add a negative 5. Now, we want to find g at 6 and f at g at 6. That's how you read that. Well, let's see. The f at g at 6, let's hold that for a minute. Let's look at g at 6. Notice that the 6 in parentheses is where the original x was in g of x. What that tells us is, everywhere I see an x, I now want to put a 6. Well, that's pretty straightforward, so let's do that. G at 6 is going to equal minus 4 times 6 minus 5. So notice all I did was I took the function g, and everywhere there was an x, I put a 6. Well, minus 4 times 6, that's minus 24, minus 5. If I have a negative 24 and I add a negative 5, I'll have a negative 29. Well, now we can look at f at g at 6. Because we know what g at 6 is. It's negative 29. So that's f at negative 29. Well, what is that? Well, let's see. Going to the f function, that's negative 29 squared minus 29. So we want the additive inverse of negative 29. That's positive 29. Notice that this solves the problem of two negatives. If we realize that negative really means additive inverse, we want the additive inverse of negative 29. What do you add to negative 29 to get to 0? That's positive 29. Well, there's where that rule comes from that many of you learned, that two negatives make positive. And lastly then, we want to subtract 2. Okay? Now, I'll leave that up to you to do that on your calculator. But that's how you would then solve it. Negative 29 times a negative 29, you're going to come up with a positive number. Negative 29 is going to be another positive number, and then negative 2. So you should end up with a fairly large positive number. Okay, that should give you a start on working through assignment 1. So what I want you to do is now take this. This will all be on a PDF that will be stored under class notes on your main menu. So you go to class notes and you can print this out if you wish and lay it down beside your homework, or you can review this video, whichever works best for you, and then fill in the others. And let me know by email or by clicking on Ask My Instructor when you have a problem you can't figure out, and I will respond to you.